Hello, welcome to Chapter 5, homework questions 126 to 132. Question 126, solve the missing side lengths and angles in the triangle below. So let's go ahead and label our triangle. Triangle ABC. So I'm missing angle A, angle B, and then side C. So I'm first going to start off by finding side C by using the law of cosines. So C squared is equal to A squared plus B squared minus 2 times AB times cosine of the included angle of 45 degrees. I'm going to plug this whole thing into the calculator and then take the square root of it. So C squared is equal to approximately 148.58. I'll leave that whole thing in the calculator and take the square root of it to get the most accurate answer. So C is approximately 12.2. Alright, so take that off and add 12.2. Alright, I'm going to solve for angle B next. This would be an angle side-side, which if you did lesson 534 would be the ambiguous case. So I don't want to necessarily use law of sines again or to solve for that one. I'm going to use law of cosines, but I'm going to set it up. So since I'm looking for angle B, I would have B squared is equal to the other two side lengths, 10 squared plus 12.2 squared, minus 2 times 10 times 12.2, and then cosine of B. Since we're trying to find B, I'm going to isolate it, and then I'll plug everything into the calculator. So it'd be 17 squared minus 10 squared minus 12.2 squared, which would be equal to negative 2 times 10 times 12.2 times cosine of B, and then we'd have to divide by negative 2 times 10 times 12.2. Same thing over here. Negative 2 times 10 times 12.2. So this whole thing right here will get plugged into the calculator, and that's equal to, because those are going to cancel, cosine of B, and then we'll have to use the inverse. Make sure when you plug it in your calculator you put parentheses on top and on bottom so it divides correctly. And so that is approximately equal to negative 0.16459-ish. And once again, anyways, I'm going to plug that into the calculator, but I have to do the inverse because I'm looking for the angle of this. And then that will give me the angle B, and you'll get angle B is equal to approximately 99.5. So angle B, 99.5 degrees. And then from there, we can take 180 minus 99.5 minus 45 to get the last angle, angle A, to be 35.5 degrees. So we have C, we have B, and then angle C is equal to 35.5 degrees. So we have solved the entire triangle. We found the missing side length. There's only one, and then we also found the angle measures. Question 127. Examine the triangle below. Solve for x twice using two different methods. Show your work for each method clearly. So two different ways. Method 1, we can just set up using Pythagorean theorem. We have x squared plus x squared is equal to 16 squared. X squared plus x squared is 2x squared. 16 squared is 256. Divide by 2. That would be, 128. And then we can take the square root, and x will be approximately 11.3. So that's one method, just using Pythagorean theorem since it is an isosceles triangle. Let's think of another way we could do this. Since the two side lengths are the same, that means this is an isosceles triangle. So if this is 90, these two angles have to be split between 90 to be equal, so they're both 45. So you could use your special right triangle, 45, 45, 90. If we're given the side length, we know that the hypotenuse is the square root of 2 times the side length. So, for example, we take x times the square root of 2, and that should equal 16. So to work the other way, we end up dividing by the square root of 2. So therefore, x is equal to 16 divided by the square root of 2. And if you plug that in your calculator, you're going to get x is approximately 11.3. If you don't want to use your special right triangles, then you can set up sine or cosine to be able to solve that as well. Question 128. In Chapter 1, you learned that all rectangles are parallelograms because they all have two pairs of opposite parallel sides. Does that mean that all parallelograms are rectangles? Why or why not? Support your statements with reasons. So does it mean that all parallelograms are rectangles? No. For all parallelograms to be rectangles, rectangles have 4 right angles. And the parallelogram does not have to have 4 right angles. It will have your congruent sides here. These sides will also be parallel. But these angles, obviously with the parallelogram, they don't have to be right angles, and that's what makes it a rectangle. Question 129, find the area and perimeter of each shape below. Show all your work. So on part A, we're finding area and perimeter. For perimeter, the only side we're missing is this one right here. So we need to find that one. For the area, we really have everything. So for A, let's go ahead and just find the area since we have all the information. The area for a trapezoid is 1/2 times the height. 6 times the sum of the bases, that would be 7 plus 17. And that will be 72 millimeters squared. So to find the side length in the trapezoid that we don't have, we do a little bit of extra work here. If we split this triangle up, that would give us 6 over here. This is a special right triangle, 6, 8, 10. You could also use Pythagorean theorem to figure that out. If this length here is 8, then this length here, based on this being 7 up here, is 7. So the total length is 17, so right now I have 8 and 7. So therefore the piece that's left on the end here has to be 2. So now I have a right triangle with side lengths 2 and 6, so we can find the hypotenuse by taking 2 squared plus 6 squared is equal to, let's call that one C squared. So that's 4 plus 36 is 40. Take the square root of both sides, and C is approximately equal to 6.3. Now we can find the perimeter. So the perimeter is equal to, we'll just work our way around. 7 plus 10 plus 17 plus 6.3. 40.3 millimeters is what the perimeter would approximately be. Alright, on part B, once again, perimeter area, we're going to have to split up here. Perimeter, we have everything except for this side length right here. A couple things here to find. This whole length is 5, but we need just up to here. We know this is 4 feet. This length here is 5. This length is 2. So that means this one is 3. And that means up here, so like this length right here would be 3. So from here to here, or from here to here, would be 2. And if that whole thing is 5, then this would have to be 3. So we kind of just worked our way over to figure that. That's a special right triangle. That would be a 3, 4, 5 triangle. And once again, you can use Pythagorean theorem if you don't remember that. And so now it looks like we have all the information to find the perimeter. I'm just going to start up here at 5 and work my way around and just add them up. 5 plus 5 plus 5 plus 2 plus 5 plus 2 plus 2 plus 4. So once again, here are the numbers that I added up. So the perimeter is equal to 30 feet. Now I'm going to erase some things in the figure because I want to split it up, and I kind of already have it split up, but let me just get rid of some of these things so we can look at it a little bit better. So we want to keep that 5 on there. So I'm going to split it up the same way that I kind of did it already. So we have the areas of the 3 different figures. We have 2 times 5, so that's 10. Here we have 5 times 4, so that's 20. And then over here we have the area of the triangle with a base of 3 and a height of 4. So 1/2 base times height, which means this would be 6. So the area, if you add all of those up, you're going to have 6 plus 20 plus 10. So the area is 36 feet squared. Question 130. Triangle ABC was reflected across the x-axis, and then the result was rotated 90 degrees clockwise about the origin to result in triangle A prime, B prime, C prime shown at the right. Find the coordinates of the original A, B, and C. Find the points of A, B, and C of the original triangle. So this is our new triangle, so we got to work our way backwards. So the last thing that happened was it was rotated 90 degrees clockwise. So we'll have to rotate it 90 degrees counterclockwise, and then we'll go back and reflect it back across the x-axis. Alright, so I went ahead and rotated about the origin, and I moved in the counterclockwise direction. And so those would be my points before I reflect it across the x-axis. So we're going to reflect it across, so now B will be here, and that's at the point 6, 2. A will be here, and that is at the point 2, 4. And then C will go 1, 2, 3, 4, 5. And that will be at the point 4, 5. So this right here would represent our original triangle that was originally reflected across the x-axis, which would have moved it down to here, and then rotated clockwise 90 degrees. Question 131. Marina needs to win 10 tickets to get a giant stuffed panda bear. To win tickets, she throws a dart at the dartboard below and wins the number of tickets listed in the region where her dart lands. Unfortunately, she only has enough money to play the game 3 times. If she throws the dart randomly, do you expect that she will be able to win enough tickets, assuming that each dart will land on the dartboard? So we need to figure out what the expected value is for winning, for playing one game. So in this region, it represents a half of the chance, 50%. Over here we have a quarter and a quarter. So we're going to use that to find the expected value. So 5 times a half plus 3 times a quarter plus 2 times a quarter. So that will equal 3.75 per game. That's what you're expected to win, how many tickets you're supposed to win per game. Well, if she has enough to play the game 3 times, then you'll take 3 times the expected value, and that will give you 11.25 for 3 games. So she needs 10 tickets. So assuming that each dart lands on the dartboard, will she have enough to get the giant stuffed panda bear? And the answer to that is yes. Question 132. Find the equation of the line parallel to the line y equals 3/4 x minus 5 that passes through the point -4, 1. So if it's parallel, we know the slope of the line is 3/4, and we know any line parallel to that will also have a slope of 3/4. And since we know it goes to the point -4, 1, we can use that information to help us find the equation. So I'm plugging into y equals mx plus b. We're going to solve for the y-intercept. We find the y-intercept to be 4. And since we know the slope is 3/4, the equation of the line parallel to that one that goes through -4, 1 would be y equals 3/4 x plus 4.